Alright, in this video we're going to look at an example of implicit differentiation, and we're going to find the equation of a tangent line. And the example that we have here, we want to find the equation of the line that is tangent to the given curve at the given point. So here's our curve, and I'm going to show you that curve right here in a second, and here's our point. So over in Desmos I have that stuff typed in, and here's the curve. This x to the fourth minus x squared y plus y to the fourth is equal to 1. So I'm just going to send that on over here. And what we want to find here is a line that is tangent to this curve that passes through this point, negative 1, 1. So we're looking for this line roughly somewhere like this, give or take a little bit. But that's what we're trying to find, okay? What we have to do whenever we want to find an equation of a tangent line, we have to find the derivative, and that's why this problem is going to involve us using implicit differentiation. It could be a pain in the neck to get y by itself in this function, so I'm not even going to bother with it. The one thing you want to be careful with is when we get right here. So let's start differentiating this thing, because that's what's going to give us our tangent slope. So the derivative of x to the fourth with respect to x is 4x to the third. And then, like I said, we have to be careful with this part right here. So I'm going to go ahead and bring down this minus, and then I'm going to focus my attention on, we have a product here. We have x squared times y. So we have to apply the product rule. And the way I define the product rule, this little first function right here, I call this f, and I call this second little piece here, I call this g. So x squared represents our f, and y represents our g, and typically that's how you see it in some textbooks. So the product rule is we do f prime, which is going to be 2x, and then we leave g alone, so that's going to be 2xy, that's f prime g, plus, now we do g prime f. Now, with implicit differentiation, when we take the derivative of this function that I've called g, or when we take the derivative of this y, we are differentiating with respect to x. So therefore, when we take the derivative of y, that's going to be 1, but we have to tack on that dy dx, or you can just tack on a y prime. So again, the derivative of g, the derivative of y is 1 dy dx, or I'm just going to write y prime. And then we multiply that by f, so time x squared. And then finishing this off, we have plus, and the derivative of y to the fourth with respect to x is 4y cubed, and then we tack on that dy dx, or you can just simply write a y prime. Just don't confuse that with y to the first that I have here and here. And this is equal to what now? You're differentiating both sides, so the derivative of a constant is going to be 0. So there is our derivative, and again, the thing you want to be careful with is the product rule right here. And take note, anytime you differentiate a function or something with a y in it, if you differentiate a y piece, you have to tack on that y prime like I did here and here. You may wonder, why did I not do it right here in this part? Because when I took the derivative of this, I took f prime, I took the derivative of x squared, which is 2x, and then I just multiply by g. I did not differentiate that y, so I don't have to tack on a y prime there, but I did when I differentiated the g in this part. I hope that makes sense. Now let's clean this up a little bit. We have 4x cubed. Differentiating across here, distributing across here, we have minus 2xy. And then minus x squared y prime plus 4y cubed y prime. So all I really did here was I distributed the negative to this term and this term, and yeah, I just rearranged the y primes right there. So when you're dealing with implicit differentiation, commonly your next step to do is to get the y primes by itself. So notice that we have a y prime in this term here and in this term here. We do not have a y prime in this term or this term. So let's take both of these terms here, and let's just go ahead and shoot them on over here to this side where we have this 0. So therefore, I'm not going to move these. So we have negative x squared y prime plus 4y cubed y prime. And this is equal to, so again, I'm leaving these two terms on the left-hand side. I'm going to shoot these two terms over here. So really all we're doing there is we're going to subtract the 4x cubed. So we have negative 4x cubed over here. And we have to add this 2xy to move it to the other side of our equation. So plus 2xy. And now that we have the y primes, all the y primes are on one side, let's work on getting that y prime by itself. So therefore we can factor out that y prime out of these two terms as a common factor. So we have negative x squared plus 4y cubed left over. And this is equal to negative 4x cubed plus 2xy. So now that we have factored out that common factor, that y prime, we can divide by all of this stuff, and that's going to give us y prime by itself. So I'm going to divide by negative x squared plus 4y cubed, and essentially all that's going to do is cancel out those two terms. Just make sure you do it on this side as well. And just like that, we have our derivative. So y prime is equal to, I'm just going to clean this up. You don't have to do the rearranging like I'm doing here. But I just, if I have a positive and a negative, it's just something I like to do. I like to write my positive term first and my negative term second. You don't have to do that. I'm going to do the same thing at the bottom. And that's going to be minus x squared. So here is our derivative. Now, all of that set aside, we're only halfway there. What we want to do now is we have to find the equation of the tangent line. So what we can do with this now, remember we have our point, negative 1, comma 1 that we're working with. And we use this point to find the derivative at this particular point on the curve, which is going to be the slope of the tangent line. So if we do m tan or y prime, I'm just going to say y prime at negative 1, 1 is equal to, so we're going to plug a negative 1 into x and a positive 1 into y's everywhere in this piece. So we have 2 times negative 1 times positive 1 minus 4 times negative 1 cubed. Notice what I did here is I just took negative 1, I plugged it into my x's, and I took a positive 1 and I plugged it into that y there. Let's do the same thing at the bottom. So we have 4 times 1 cubed minus negative 1 squared. Grab your calculator if you want, but this isn't really too crazy since we're just plugging in negative 1s and 1s. So all of that right there becomes negative 2. Negative 4 times negative 1 cubed. Well, negative 1 cubed is negative 1 times a negative 4, so that's plus 4 over 4 times 1 cubed is 4, and minus negative 1 squared, that's still going to be a 1, a positive 1 right there. So we have 4 minus 1. Therefore, we're looking at a slope of 2/3. This is going to be our m tan, or whatever you want to call it, the slope of our tangent line. So now, once we have this, we can come and we can find the equation of that tangent line, just using a little bit of algebra here. I'm going to do point slope form, so y minus y1 equals m times x minus x1, and I'm going to put this equation in slope intercept form. So we're using our point, and we're using our slope, and we're going to plug that into point slope form. So therefore we have this, y minus y1, so y minus 1 equals m, that's our tangent slope, so 2/3 times x minus x1. So since I'm subtracting a negative 1, that's going to be plus 1 there. Now you can leave it just like that, but I'm going to go ahead and go one step further and put this in slope intercept form. So distributing the 2/3, we have 2/3 times x plus 2/3, just distributing here and here. And now let's add 1 to both sides. So adding 1. Try to do this stuff in your head because you may have a test that's not calculator active. So 2/3 plus 1 is the same thing as 2/3 plus 3/3. Therefore we have plus 5/3. So this is our final answer. That's the equation of our tangent line. So to verify this, the slope's 2/3, the y-intercept's ugly, it's not a whole number. But if we just go back into Desmos and we type in the equation of that line that we just got, so y equals 2/3 x plus 5/3, check that out. So that's that blue line. Ironically, it's the same color as this blue that I had here. But notice that was the line that I was kind of saying we were looking for at the beginning. And notice that is exactly what we have going on there. So that is that line that's tangent to this curve, this weird looking curve, at that point negative 1, 1. And there you have it. That's an example of using implicit differentiation to find the equation of a tangent line. And that is it for this video. I hope it helped.